So by clicking on Mesh in the object tree, we can see in the details view different types of defaults that will be applied. So we can see that the physics preference for the mesh is mechanical. If you're doing something like a CFD analysis or a nonlinear mechanical analysis, you could go ahead and change the type of physics preference as required. But we're going to just leave this as mechanical for right now. Now you also have some options for the default sizing of the mesh. So expanding this function right here, you can see that you can choose different types of sizing options. And one of the most important ones here is the element size, which if you click on here is default, but you can change this to any value you want. And then finally you have down here the statistics tabs, which tells you the amount of nodes and the number of elements that the mesh has created. So as you can see here, we have a lightning bolt, which means that it's ready to be generated. So let's go ahead and just see what the standard mesh will give us. Now to do that, you can either click on the mesh and click on this update button right here, or you can right click on the mesh and click on generate mesh. Now let's say your model was a bit too big, you can go and just click on preview surface mesh, which will generate a very quick mesh on the surface and won't model the 3D elements on the inside. So let's go ahead and click on the preview and surface mesh and see what that gives us. So there you have it. There's the default mesh given by ANSYS. Now if you want to do a full mesh, we can right click on this and then click on generate mesh. As you can see, this mesh is somewhat coarse, and the elements here are a little bit too big for this analysis. Now the reason I say this is because if you look at the lifting lug, you will see that there is only one element across the thickness of the lug. And as a general rule in finite element analyses, you typically require mesh with multiple elements through the section in order to capture the stress and deformation gradients more accurately. So before refining the mesh in this area, let's go ahead and see the statistics on this mesh that was generated. We can see that we have about 4,000 elements and 15,000 nodes. So to refine the lifting lug model, let's go ahead and right-click on the mesh, and what we're going to do here is click on the Insert tab. Now here you have a few options. The first one is called the method, which will determine the type of meshing algorithm used. To name a few would be the tetrahedron or hex-dominant methods. The next one is called sizing, where you can change the size of the elements. After that we have contact sizing, which creates elements of the same size near the contact area. And then we have refinement, where you can select specific areas to refine in the mesh. And finally, we have a few other options which I won't get into for this lesson. So let's go ahead and choose the first one, which is the mesh method. So after clicking on mesh method, we can see now that we have something called the automatic method, which has been selected by default. And to the left, we have a question mark, again indicating that some parameters are missing in the details window. So the first thing it asks us is to select the geometry for the method that we're choosing. So in this case, we're going to select the whole model. In order to do that, let's switch from the single select mode to the box select mode right here. Now with that selected, let's drag over the whole model and select all the objects in our model. Now once that's done, click on the no selection here in the geometry and click on apply. Now we see we have 14 bodies selected. Now under the method here, under definition, we can change this from the automatic method to a few other options. Some of the other options are tetrahedral elements, hex-dominant elements, sweep method, and a multi-zone method. Now tetrahedral will only allow tetrahedral elements to be created in the mesh. Hex-dominant method will try to convert as many tetrahedral elements as possible to hexahedral. The sweep method tries to create a mesh with wedge elements that are suitable for rounder or curved based objects. And finally, the multi-zone mesh method, which is a patch-independent meshing technique, which can decompose the geometry into mapped regions and free regions, so therefore you can have a combination of hexahedral and tetrahedral elements at the same time. So in our case, we're going to choose the multi-zone option, since we have both rectangular-shaped objects and sweepable objects. Now after clicking on multi-zone, we can see that the mapped mesh type is hexa, which is what we would like in our case. And for the other controls, we're going to leave them as default for now. Once that's done, let's go ahead and right-click on the mesh and click on Generate to see a preview of what we have so far. After applying the multi-zone method, we can now see that the lifting lug's elements have been somewhat converted from tetrahedrals to hexahedral elements. This is better because if we look at the mesh count, we can see now that we've reduced our number of elements from about 4,000 to 2,500 elements. However, we can see that these elements are still slightly too coarse for this analysis. So I'm going to go in and right-click on Mesh, Insert, and now we're going to use the option called Sizing. So let's click on that right now. Now once sizing is selected, it'll ask you again to select the geometry that you would want to apply a sizing to. So in this case, we're going to go to the body filter, change our select mode to single select, and we're going to select the lifting lug. And then we're going to click on Apply. Now in the definition here, we can change the element size. So instead of having default, we're going to change this element size to 5 millimeters. Now once that's done, let's go ahead, right-click on Mesh and click on Generate Mesh again. Now we have a much more refined mesh for lifting lug. Now I can't really see the mesh of the bolts clearly, so let's go and hide the base by right-clicking on the base and clicking on Hide Body. And let's also hide the lifting lug by clicking on the lifting lug, right-clicking, and then clicking on Hide Body once again. Now if I zoom in, we can see that we have the mesh of the bolts, which are not too bad. However, in this region, we're going to apply a preload, so we want to have the mesh slightly finer than what it is right now. So in order to refine the mesh in these regions here, we're going to right-click again on Mesh, and we're going to insert another sizing. Now, instead of using the body filter, we're going to click on the face filter. And we're going to select each one of these faces using the Control key. Now, once all 4 faces are selected, click on the Apply under the geometry. Next, under the element size, we're going to change it from the default to 2 millimeters and hit Enter. Now let's go ahead and update, and this time using this button right here. Now in order to see the mesh, let's click on the mesh object here in the outline window. Now you can see it divided the mesh here with 2 millimeter spacings instead of the default value. Now that the mesh of the bolts are good, we can right-click in the graphics window and click on Show All Bodies to show all the bodies again. Now as you can see, after applying the face sizing, we get some error messages that says the selective body meshing is not being recorded, so the meshing may be not persistent on an update. This is just telling us to double check our meshing every time we update our geometry. So we can go ahead and ignore this message for now, and we can close out the messages.